So this is our Exam 5 over Chapter 6 Material Review video. I'm doing this for two reasons. One, in your particular, the way I've designed this particular exam, I'm asking you to solve things in a very specific way, and I literally tell you the process. So the good way about how this exam is being done, which is being done completely different from your prior exams, is that you don't have to remember what to do almost as far as the process, because I tell you step by step. And I wanted to give you a review where that process is incorporated in the review. The second thing is, it's not necessarily true that the problems that I work out here are going to be identical to the problems that you see on the exam. What I've done is these are going to be some work-intensive problems, and that's one of the reasons I've cut down in the total number of problems. But also, it's the reason I've broken them down into steps. So I wanted to do this where I actually break them down into steps. So the first problem we're going to do is we're going to multiply. We've got a rational expression times another rational expression divided by a third rational expression. So the first thing I will tell you to do is the following, and this is going to be a really important part. You have to factor all numerators and denominators. And that's really going to be so much of the heart of this particular exam. You have to show your work, all of it. And I will give you some instructions in the announcement I post on how that can be done. The easiest way to show your work is to factor them exactly the way I've showed you and the way I'm going to do it right now. So we're going to factor 3x squared minus 5x minus 2. So using the method that I think is really easy to do, we draw the little tic-tac-toe box, kind of. We take our leading term, 3x squared, our last term, minus 2, that's a minus, and minus 5x. So I'm just going to do this. I'm just going to do that for all of these, because the methodology here has already been explained to you in our chapter 5. So what's good about 3x squared is the 3 is prime. So that gives me no choice but to put 3x there and an x there. Minus 2 is also prime. So it's either going to be minus 2 times 1 or 1 times minus 2. And the order we put them in this box is going to depend on what we need down here. So I'm going to say let's try minus 2 times 1. So minus 2 times 1 is minus 2, and now we multiply down the column. 3x times minus 2 is minus 6x, and x times 1 is plus x. So we're adding in this last row right here. Minus 6x plus x is 5x. So all of my conditions are satisfied. So I get the factorization. Remember, go kitty corner. 3x plus 1 times x minus 2. So x minus 2. And it doesn't matter, you could have done x minus 2, 3x plus 1. So I factored the first numerator. We're going to do this on all of them. I literally, what I would suggest you do right here is I would try to factor all of these on your own, and then maybe come back and watch the video and see how many of them you got right. You should get them all right if you know what you're doing. So here I have y squared minus 3 and 2y. So y squared, I have no choice, put a y right there and a y right there. So y times y is y squared. So minus 3 is prime, and it has to add up to a 2y when I multiply vertically. So I'm going to put 3 and minus 2. So this gives me 3y. Sorry, not minus 2, but minus 1. There we go. Minus y. And 3y minus y is 2y. 3 times minus 1 is minus 3. So my factorization is going to be y. Now notice that minus right there. Y minus 1 times y plus 3. So let's go on. I'm going to do my second one. And we want to factor y squared. So clearly good factorization skills are going to be important. And there's no option for you but to show your work in detail. And if you do factorizations a lot, the really question is, how do you find the split to get you the middle term? So here I need a y squared, a minus 6, and a 5y. Since this is y squared, I have no choice to put a y and a y. Minus 6, there's several factors, but when I add them up, I have to get a 5y. So I'm going to put 1 and minus 6. So minus 6 times y is minus 6y. Y times 1 is plus y. Minus 6y plus y is not 5y. So I've done something wrong. So let's fix it. Let's change my 6 to a positive and my 1 to a minus. And that's going to make all of the difference in the world, because now I have y times 6 is 6y, and y times minus 1 is minus y, and 6y minus y is 5y. So I have my factorization. Y minus 1, y plus 6. Remember to go kitty corner. It's a shame if you forget and do all of this work correctly, but in the end write down the factorization wrong. So the next one is 12x squared plus 7x plus 1. So again, you just quickly draw your little table. 12x squared, that's not prime, but the nice thing is that 1 is. So down here, for this row here, I only have the choice of 1 times 1. You could also do minus 1 times minus 1, but that would force our middle term to be a minus, and we don't want that. So I have to figure out how do I split up 12 factor-wise? Well, let's try 4x times 3x. So 4x times 1 is 4x. 3x times 1 is 3x. 4x plus 3x is 7x. So I have my factorization. It's 4x plus 1 and 3x plus 1. And finally, we want to do our last one. We'll kind of just scoot it over here. This work will all be required for the exam. I definitely want to see all of your work on this one. So 7x squared minus 12x minus 4. So again, 7x squared, and minus 4, and minus 12x. Need a little bit more room here. And write that a bit bigger. Minus 12x. So the nice thing about 7x squared is 7 is prime. So it's going to be 7x and x. So there's some choices with 4. I could do minus 2 and 2. Well, let's just do that. Minus 2 and 2. So 7x times minus 2 is minus 14x. And x times 2 is plus x. 2x, sorry. Plus 2x. Why am I running out of space here? Anyway, that's minus, rather than erase things, that's minus 14x plus 2x. And indeed, that's equal to minus 12x. So they're all checked. And my factorization is 7x plus 2 times x minus 2. Then the last factorization is 8x squared minus 10x minus 3. So immediately just start it out. Try to figure it out. So 8x squared, let's just get some more room here. 8x squared. Then minus 3. It's good, that's prime. And then minus 10x. So minus 3, I'm going to do minus 3 and 1. For 8x squared, let's do minus, so not minus, sorry. There's never minuses in the first row. 4x and 2x. So 4x times minus 3 is minus 12x. And then 2x times 1 is plus 2x. And minus 12x plus 2x is indeed minus 10x. So all of my boxes are checked. So the factorization is 4x plus 1, 2x minus 3. So I've got all of my factorizations here. So now what I actually ask you to do, although I may not do it exactly in the same words, is to rewrite my original problem using the factorizations. Now I have those written out, and I'm just going to look down on my paper and write them down. So what I'm doing is I'm rewriting all of this right here, just in case you know. I mean, it never hurts. Some of you, that's one of the bad things about teaching online, is usually I can look into the classroom and tell by your eyes if you're following me and who isn't and who is not. So what I'm going to do is rewrite, instead of 3x squared minus 5x minus 2, I'm going to replace it with this factorization right here. So here's the factorization of 3x minus 5x minus 2. I'm going to replace it with this. In each case, all of these are going to be replaced. And when I do that, I get the following. Then I'm multiplying in my second rational expression with the numerators and denominators factored is y minus 1. And then this is a division. Okay. So the next thing I do is I literally tell you we're going to use PEMDAS here. So this is has a multiplication and a division, and PEMDAS says you just do them in the order that they occur when you move from left to right. And that's equivalent to doing what's in parentheses first. So do the multiplication first. I don't know if I say it in those exact terms, but I do ask you to do it. And the cool thing is, and the reason I can do what I'm about ready to do is because that is multiplication. I couldn't do what I'm getting ready to do if that were not multiplication. So remember, A divided by B times C divided by D is just AC over BD. Fraction multiplication is the easiest. And what am I want to do? I want to eliminate any common factors that are in the numerator and also in the denominator. So you just focus on the numerator, and this is 1 factor, 2 factors, 3 factors, 4 factors. So I go factor by factor and see if that same factor is in the denominator. So let's start with 3x plus 1. Do I find a 3x plus 1 in the denominator? And yep, I do. So that means that 3x plus 1 factors cancel. Now let's go to the x minus 2. Is there an x minus 2 in the denominator? No, so it remains. What about y minus 1? Ah, there's a y minus 1 right there. So the y minus 1's cancel. What about y plus 6? There is no y plus 6. So the simplification, what's done right here in parentheses, is you just write my factors, the remaining factors, x minus 2 times y plus 6 divided by y plus 3 times 4x plus 1. And then the next thing I ask you to do is to divide by, and I'm not going to write it down, but this is what I'm going to divide by. And what do I do to divide by? Well, I have a division sign there. I would really like to turn it into a multiplication sign. And I can do that. I just did it. I just wrote down a multiplication. But I have to pay the price. Remember what that price is? This term right here has to become its reciprocal, which just means that the denominator becomes the numerator, and the numerator becomes the denominator. And then the next thing I'm going to do is I will tell you to simplify in some order. So again, since this is multiplication as well, I can do what I'm about ready to do. So I'm going to start with x minus 2, and I'm going to look to see if there's an x minus 2 factor in the bottom, and there is right there. So that means the x minus 2 factors cancel. Is there a y plus 6 factor in the denominators? No, it remains. Is there a 4x plus 1 factor down there? Yes, there is. What about a 2x minus 3? There's not. So the answer is, here's my division line. You just write down the remaining factors in the numerator that did not get canceled out, which is y plus 6 times 2x minus 3. And then y plus 3 times 7x plus 2. And you're done. This is the answer. do not multiply it out. You spent all of that time factoring. When you multiply it out, you lose information. So leave it exactly as it is. Okay. So the next problem that you might see is to simplify a complex fraction. So we're going to simplify 7 divided by x. This is in the numerator of the complex fraction, over 8 divided by x squared. Now our main division line is that one right there, and y over x squared. And the first thing I will ask you to do is to find the LCD of the denominators. And what by that I mean the denominators in the top expression and the denominator in the bottom expression. So I'm literally looking for the LCD of x and x squared. And I'm hoping you are fine with saying that is just x squared. In general, if we have the LCD of two terms and one of the terms is divisible by the other, x squared is evenly divisible by x, then we use the term with the highest power. I've shown you how to do that. When you have variable terms and you're looking for the LCD, you just grab the term with the highest power. So the next thing we're going to do is we're going to clear denominators. Clear denominators. And by that I mean the denominators in this top expression and also in the bottom expression by multiplying by the LCD divided by the LCD. The LCD divided by the LCD is 1. So that's what I'm going to do. Since this is a term, it's a sum of two terms, I'm going to put those in parentheses, and I'm multiplying it by the LCD. The LCD is x squared. And it might help you if I put x squared over 1. And I'm going to do the same thing to the bottom. I'm going to multiply it by x squared over 1. What I do to the, if I multiply the top by something, I have to multiply the bottom, meaning the numerator, and the denominator by the same thing. So here, literally, all I'm doing is distribution. Remember, this is just distribution. So clearing the denominators, 7 divided by x times x squared is 7x. 8 divided by x squared times x squared is just 8. Over here, y divided by x squared times x squared is just y. So notice, what do I mean by clearing the denominators? In my above the division line, I just have a polynomial, no fraction. Below the division line, my numerator, just a polynomial, no fraction, and I'm done. There is no further simplification because 7x plus 8 is a prime polynomial. So the next problem we're going to do requires that I solve for x. So the first thing I request that you do is to factor the denominators, factor, rewrite find LCD. So that's what I'm going to do right here. There's nothing that can be done with my first denominator. It's a prime polynomial. I can't factor it. But for my second denominator, x squared minus x, the GCF is x, so I can pull out an x. X squared divided by x leaves me an x. Minus x divided by x is minus 1. So that's the factorization of the denominators, and this is the rewrite. So I've taken care of the factorization and the rewrite, so I find the LCD, and by that I always mean find the LCD of the denominators. So my LCD of the denominators is x minus 1 times x minus 1. Now this should be obvious to you, but let's just pretend that it's not. I'm going to show you how we can use our table method. Prime factors. In this case, the table method that I taught you on how to find the LCD. And then I have the denominator 1 is x minus 1, and denominator 2, x times x minus 1. Now if you're uncertain, you might want to put these in parentheses. So what are my prime factors? X minus 1 is a prime polynomial. Then I have x times x minus 1. Well, that's the product of two factors. X minus 1 is prime, but I already have it there. But I don't have the x, so let's put my x here. So let's go down the list. How many factors of x minus 1 do I have in x minus 1? 1. Now here's the only one you have to think about. How many factors of x do I have in x minus 1? The answer is 0. Not 1, 0. X minus 1 is prime, x is prime. X minus 1 x is not a factor of x minus 1. I cannot factor out an x from x minus 1. It doesn't matter that it has an x right there. The value of the factor is x minus 1. So 20 has a factor of 10, but 20 minus 1, which is 19, doesn't have a factor of 10. Over here, the same thing. How many factors of x minus 1 do I have in x times x minus 1? That's 1. How many factors of x do I have? I have 1. So my LCD is equal to x to the, we circle, remember we circle the largest number in each row. So my LCD is x raised to the first power times x minus 1 raised to the first power. So that's my LCD. So then I say clear denominators. Clear denominators. And how do you clear denominators? You multiply both sides by the LCD. Since the left-hand side is a sum, or actually a difference of terms, I put those in parentheses. I'm going to go ahead and put the 2 in parentheses too. It's really not needed. And I'm going to multiply times x minus 1 times x minus 1. And I'm going to simplify. X times x minus 1 times 4 divided by x minus 1. The x minus 1's cancel, so I get 4x. X times x minus 1 minus 4 divided by x times x minus 1. Well, the x times x minus 1's both cancel, so that gives me minus 4. And this is equal to 2 times x minus 1. This is equal to 2x times x minus 1. And then I tell you to solve for x. But I'm going to pause right now because I actually just remember I tell you this is the point. After you find the LCD, I ask you to set the LCD equal to 0 and find values of x which must be excluded. So you can do it either way. You can set both denominators equal to 0 or the LCD, but that just means I solve the following. X times x minus 1 is equal to 0. So that means either x is equal to 0 or x minus 1 is equal to 0. And if x minus 1 is equal to 0, that implies x is equal to 1. So the values of x is equal to 0 or x is equal to be 1 may have to be excluded. We don't know until we get our final answer. But if the final solution set contains either 0 or x is equal to 1, we have to exclude it. So you could do that at the very end, but I'm pretty sure on the exam I ask you to do it before we get to the very end. So we're here at this point. Solve for x. So let's solve for x. I'm going to notice on my left-hand side I can factor out a 4. 4x divided by 4 is x. Minus 4 divided by 4 is minus 1. So here's the way I'm going to do it. You have two options. You could just multiply everything out. You'll have a quadratic equation you'll have to factor. But I'm going to do it this way. I'm going to observe that I can divide both sides by 2. And I've maintained the equality. So 4 divided by 2 gives me 2. 2 divided by 2 is 1. And I'm noticing that I have a factor of x minus 1, and that's making me happy. So I'm going to move everything to one side. So I'm going to move the x times x minus 1 over. And that means that's a 0. And I'm noticing the common factor of x minus 1 and x minus 1. So I'm going to pull that x minus 1 out. So 2 times x minus 1 divided by x minus 1 leaves a 2. Minus x times x minus 1 divided by x minus 1 leaves me an x. And I'm ready to solve. So x minus 1 times 2 minus x is equal to 0. That means x minus 1 is equal to 0, or 2 minus x is equal to 0. Well, this top simple linear equation implies x is equal to 1, and the second implies that x is equal to 2. So here's where I need to check. And over here I discovered that x cannot be equal to 1. So that means this is not an acceptable answer. So my only answer is that x is equal to 2. That is the only solution. You might say, what happens if I had x is equal to 0 down here? Well, then it wouldn't be a solution either, and there would be no solution to the problem. Before I move on, this factorization trick, I have a feeling none of you will do it. So I'm going to show you the other way, I'm not going to work through the whole thing, but I'm going to show you what I feel many of you will do. So starting right here at this step, you can get to here. I have a feeling you're going to do this. 4x minus 4 is equal to 2 times x times 2x times x is 2x squared minus 2x. Okay, good. What do you do to solve that? There's only one way. This is a quadratic equation. You have to move everything to one side. This is a degree 2 polynomial, and I want the leading coefficient to be positive. So I'm moving the 4x minus 4 to the other side. So the 4x becomes minus 4x, and the minus 4 becomes plus 4. So this is 0 is equal to 2x squared minus 6x plus 4. And the only way you can solve this is all the way back to the previous exam, is to factor. And once you factor this, you set each factor equal to 0. And guess what? You're going to get x minus 2 and 2 minus x. Actually, we're going to do something a little bit simple. You won't actually get this from here. What I want to notice is I'm going to factor out the GCF. So that's 2. That's 2, 6, and 4 are all divisible by 2. So now you just have to factor x squared minus 3x plus 2, and that's when you're going to get this factorization right there, and that's when you'll set each factor equal to 0. Okay, next problem. So the next problem, we're going to add the dreaded adding of rational expressions. So I have x plus 4 over 5x squared minus 17x. Yeah, you have to be really good at factoring here. Minus 12. So if you're weak at factoring, you gotta take care of that weakness before this exam. You'll see why when you read my explicit instructions later on tonight. Now again, the good thing about this part is I literally tell you what to do. I break it down in parts for you. So the first thing I tell you to do is going to be to factor, guess what? The denominators. And rewrite. When I say rewrite, it means rewrite with the denominators factored. So let's go ahead and factor. I'll do it over here. I'll scoot this over. Let's factor 5x squared which by now should be a piece of cake. I have a new setup here. I had to get a keyboard. I type so much it's killing my hands, and I have my laptop kind of up in the air, and I'm wondering if the video's jerking. I'll check it and see if that's the case. I'll do something to prevent that in the future. If it is now, I hope it's minimal and you can live. Since 5 is prime, the top is easy. And let's do minus 4 and 3. So that gives us minus 20x plus 3x. So minus 20x plus 3x is minus 17x, so everything's done. So this factors to 5x plus 3 times x minus 4. Let's do the next one. 3x squared minus 7x minus 20. So I'm going to let you all do that. I'm just going to tell you what the factorization is. It's 3x plus 5. I've done enough of these factorizations. You can actually go through the method and figure it out on your own. Times x minus 4. No, that's not right. Yeah, x minus 4. Just making sure I read right. So I factored the denominators, so let's rewrite it with that factorization. So this is the same as x plus 4 over 5x plus 3 x minus 4 plus x, it is plus indeed, yeah, over 3x plus 5 x minus 4. So there's the rewrite. And then what I ask you to do is to find the LCD. LCD of the denominators. So I want to find the LCD of 5x that's prime, x minus 4, and 3x plus 5. I already have x minus 4 up there. So really, this is a piece of cake. All 5x plus 3 is prime, can't factor out anything. X minus 4 is prime, can't factor out anything. 3x plus 5, prime, can't factor out anything. So the LCD is just their product. So the LCD of 3 prime distinct numbers is always their product. So the LCD, and let's write it over here. And it's going to be a big, huge part. And many times we're just going to write the LCD until the very end. It's equal to 5x plus 3 times x minus 4 times 3x plus 5. And my final answer is going to be over the LCD. Now what I ask you to do is we're going to find our k values. I want you to find k1, which is equal to my LCD divided by my first denominator. And I want to find the value of k2, which is also my LCD divided by the denominator. Well, the LCD is 5x plus 3, x minus 4, 3x plus 5. So the 5x plus 3 will cancel, the x minus 4 will cancel, and it leaves me 3x plus 5. Down here, the LCD is 5x plus 3, x minus 4, 3x plus 5. So the 3x plus 5 will cancel, and the x minus 4 will cancel, leaving me the 5x plus 3. So now I'm ready to add. So the final, well, next to the final, is I can add my 2. I have everything I need. It's all going to be over my LCD. So I multiply my first numerator times k1. Then I add my second numerator times k2. So that's what we're going to do. Well, my first numerator is x plus 4, and my k1 value was 3x plus 5. My second numerator was x, and my k2 value is 5x plus 3. And all of this is over the LCD, and I just write LCD until the very last step. There's no reason to repeat all of that. So what do? I have to simplify the numerator. There are no common factors to factor out, so x times 3x is 3x squared. X times 5 is 5x. 4 times 3x is 12x. 4 times 5 is 20. I might need some more space. X times 5x is x times 3. So now I collect like terms. 3x squared plus 5x squared is 8x squared. 5x plus 12x is 17x, plus 3x is 20x. And then I have my constant term is 20. And I'm not quite ready. And to be honest with you, in the exam, you don't even have to write out the LCD. As long as the LCD is written down somewhere, I don't care so much, as long as the LCD is correct. But of course, I will write it out here. Notice that 8, 20, and 20, I can factor out a 4. So I can simplify the numerator a little bit. So I'm going to factor out a 4. 8x squared divided by 4 is 2x squared. 20x divided by 4 is 5x. And then my LCD, which I guess it is a good idea to write it out, is 5x plus 3. Remember, you have this written down earlier, so all you have to do is look up and copy it correctly. 3x plus 5. And we're done. And that is the final answer. Do not multiply out. Leave factored. So the next, this is a pretty, I'm going to tell you, and it's not to scare you, but you have to study a lot for this one. This is always, this particular exam, we have the lowest exam scores in intermediate algebra than any other exam. That's the reason I'm doing all this prep work for you, breaking down problems into small steps and reducing the number of problems for you to do. It's less than 10. I don't remember how many it is. So now you have to do polynomial division. I've also made it, this is going to be the differences, there is absolutely no way you can use any other app on your screen that I can't see. You won't be allowed to touch your keyboard for this particular exam. So how do we do this? Well, we do long division. In this case, we always have to write, not the best, I don't like that. At least for that top line, it can be straight, right? I don't care so much about the vertical. So we have to make sure that we write things in descending order of powers, or degree. So that's degree 4. Now next has to come my degree 3. If there were not a degree 3, I'd write 0 times that degree. But in this case, every degree is present, so I'm good to go that way. So here is the polynomial long division. So come over here on the side. So remember, the focus is always on the x and this term. Each term as we go down. Of course, it won't be minus 14x3. You'll see. So let's look at our leading term. 2x to the fourth divided by x. That's 2x to the third. So I put 2x to the third. Now I multiply 2x to the third times this binomial. So 2x to the third times x is always going to be the same as my leading term up here. That's by design. Then 2x to the third times minus 6 is minus 12x cubed. So now I do a division. I mean, not a division, a subtraction. Now if you want, you can put plus 0, plus 0, plus 0. It doesn't matter. But this is the part you have to be really careful with. You flip on the two terms here that I've written in yellow, you have to change their sign. That becomes a negative, and this becomes a positive. And you add. When you add, the first leading term right there is always going to be 0. 2x to the fourth minus 2x to the fourth is 0, so I'm not even going to write it down. Minus 14x cubed plus 12x cubed is minus 2x cubed, and you have to make sure you get that right. So minus 2x cubed, and then you just bring the others down. So now the leading term we're going to focus on is minus 2x cubed. So again, this is side work. So minus 2x cubed divided by x, you're always dividing by that term, is minus 2x squared. So that's what I put up here for my next step, is minus 2x squared. So minus 2x squared times x is minus 2x cubed. Minus 2x squared times minus 6 is plus 12x squared. Now I'm ready to do my subtraction. You can put zeros there if you want, but what you must remember to do is to change the signs and add. So the minus becomes a plus, and the plus becomes a minus. Now we're going to add. So by design, the first terms will cancel out. So minus 13x squared, plus 13x squared minus 12x squared is x squared. Then minus 7x plus 6. So again, I take my leading term x squared and I divide by x. That's equal to x. So that's my next term in the quotient. X times x minus 6 is x squared minus 6x. Now I do the subtraction step. And I change signs and add. That becomes a negative, and this becomes a positive. X squared minus x squared is 0. Minus 7x plus 6x is minus x. And then minus x divided by x is minus 1. So up here, my next term in the quotient is minus 1. That's my last term. So minus 1 times x is minus x. Minus 1 times minus 6 is plus 6. And that's kind of nice because when I change my signs and add, I get 0. And that is my remainder. Remainder is equal to 0. So this is my answer right here. This is the result of my division. Right there. 2x cubed minus 2x squared plus x minus 1. So 2x to the fourth minus 14x squared plus 13x squared minus 7x plus 6 divided by x minus x is equal to this right here in yellow. Okay. One last one, and that's going to be it for the review. There's going to be some reading problems on there, and I treat those in 6.6. It's your latest lecture, and I figure those are the ones that are the most prominent on your head. So that's an S is equal to D times A plus H divided by 2. So again, if you do all of the practice, all of the problems on the practice exam, you will be very, very well prepared for this exam. So how do we solve this? You're asked to solve for D. Yeah, D. And I don't give you any steps to do this. You can do it however you want. The way I want to do it is clear the denominators. That means, well, I've only got one denominator, so I multiply both sides by that denominator. When I multiply D times A plus H divided by 2, the 2's cancel. And I got D times A plus H. Now if you want, you can write the variable you're going to solve for in a different color, because that's the one that has to be on one side of the equal sign all by itself. So in order to get the D by itself, I just divide both sides times A plus H. And you can put it in parentheses as you want. And when you do that, notice that the A plus H factor, they cancel. So my final answer is 2s over A plus H is equal to D. So I solved for D. So if you have questions about anything that I've done in this review, feel free to send me an email. And this is what you need to study. Like I said, I've restricted and made things easier. I've reduced the questions, but this is a hard one. So there's a lot of skills you need to learn. So learn them. And this exam that is normally a difficult one won't be difficult at all.